So symbiosis, and when you think of the term symbiosis, maybe you're going back to some, elementary, middle school biology or high school biology, where they talk about the clownfish, little Nemo there, and he can live in the sea anemone and other fish can't. The sea anemone has some stinging tentacles to it. The clownfish has an adaptation that allows it to be immune to that stinging in the anemone. And so as a result, the fish gets to live within the anemone. It gets protection from other predators. So it has a relationship with the anemone. This is a symbiotic relationship. This is actually a mutualistic relationship because the sea anemone actually benefits as well. The clownfish eats away dead tentacles from the sea anemone. The clownfish excrement actually fertilizes, if you will, the sea anemone and gives them nutrients from that. So this is definitely a symbiotic relationship. And we have a symbiotic relationship with our microorganisms as well. We have, oops, sorry. We have up in the top here, we've got the gray cells, the brownish tan cells are our eukaryotic cells. All the little pink ones are bacteria. And this is bacteria that's living in our nasal cavity. And all of us have bacteria living in various places throughout our body, and that's normal. And most of the time, the bacteria doesn't harm us. It's a commensal relationship where the bacteria is benefiting because it has an environment in which to live. The bacteria don't harm us, so we are neither negatively or positively affected. So that's a relationship. So symbiotic relationship happens with microorganisms as well. The termite, this is a kind of neat one because the termite has symbiotic relationships with bacteria just like we do, and protozoans and other microorganisms. The termite, okay, so we live in Houston, you know what termites are. Termites eat wood, right? We're trying not to have them in our house. Would it surprise you if I told you that termites can't digest wood? They eat it. They take it in, but they actually can't digest it. There is actually inside the termite's gut a protozoan. And inside that protozoan is a bacteria. And the bacteria makes an enzyme that breaks down cellulose. The termite doesn't make this enzyme. The bacteria makes down the enzyme. The protozoan has the bacteria in its system. The protozoan can move. The protozoan invades the termite, establish a colony in the gut of the termite, carrying the bacteria that make the enzyme that breaks down cellulose, which is going to provide nutrients not only for the bacteria, but for the protozoan and the termite. So this is a mutualistic relationship between all of these microorganisms and a termite. So definitely a complicated system. Something happens. So what do you need to know? Let's define symbiosis. Symbiosis is relationships between organisms, and in particular in this course, we're going to talk about microorganisms and their host. We've talked about mutualism, where both members benefit. So the termite and the protozoan and the bacteria are all in a mutualistic relationship. They all need each other to survive. In this case, there's 3 organisms, so we would put 3 pluses here. This is a shorthand when you're describing symbiotic relationships. Commensalism, that's where many of the bacteria that live on us, we provide them a habitat. They don't harm us, so this is a commensal relationship. Though more and more we are finding that this microorganisms that we carry, this microbiome, they're providing more benefit than we realized. So we are finding out that more and more of our relationships are mutualistic. And when those bacteria disappear, it becomes an issue. Now, parasitism, this is another type of symbiotic relationship. This is when one member benefits and the other is harmed. All pathogens are in this category by definition. Pathogen is a microorganism that can cause a disease, which means a disease is a change in state of health where they're being harmed. So all pathogens fall into this.